I'm happy to be here today to talk a little bit about the moon. And I call my talk Cislunar Space, the Next Frontier. You may wonder, since I'm sort of known as a lunar scientist and as a lunar advocate, why I've suddenly shifted gears. Well, I haven't really. The point I'm trying to make is that I think that the movement of people into space takes place in steps and stages, and Cislunar Space is the next step. When we look back at the history of the space program, we've sort of had three ages of spaceflight. The space age we're all familiar with occurred from the 50s and to the 60s, where we're racing the Russians to the moon, and that was the dominant objective, and that was one that was achieved. But at the same time, we learned in the 60s the value of space, utilitarian value, and that came from as a result of launching satellites that did things like monitor Earth resources and they created communications relays. Those kinds of things were documented and demonstrated and then basically transitioned to the private sector. So that template of the first space age kind of set the model that we've come to expect for NASA. NASA does the things that pushes the envelope that are hard, and then they move on to the next challenge. The middle age I'm calling sort of the what now age, is after we went to the moon, it wasn't clear what the next step was. The country was not ready to support a vigorous effort to go beyond the moon. So effectively we returned to Earth orbit, and we focused on trying to make access to Earth orbit routine. We didn't quite succeed in that. However, we did learn a lot as a result of the shuttle program and the station program, both of which had troubles along the way. They were questioned in terms of their value, they were questioned in terms of their mission and purpose. I think in retrospect, I see very clearly what they have taught us, and it's a great deal. But another issue that arose at the same time was, is space a place for people or machines? Do we want to send people? Why do we have a human space program? Those questions began to be asked in this age. The current age, I'm going to call the beyond LEO age, beyond low Earth orbit. And everything is in total chaos. Everything is up in the air. Where are we going? What's the purpose? And what is the value of space? What's the new value? Now, basically, I'm looking at this from the perspective of creating a long-term, permanent human presence in space. What's the problem? What's the fundamental issue? I contend that the fundamental problem is that we cannot lift out of the Earth's gravity well everything we would need to create thriving human communities in space. So what that means is we have to learn how to use what we find in space to create this capability, to create this sustainability and habitability. As long as we are limited to what we can lift out of the Earth's gravity well, we will be mass and power limited in space and therefore capability limited. So the key to breaking that, to breaking what my friend Don Pettit calls the tyranny of the rocket equation, we have to learn to use what we find in space to create this new capability. So the current template is largely design a specialized vehicle, launch it on an expendable rocket, operate it for a bit and abandon, and then repeat that template. What we want to do is transition to a new template, a template that basically uses incremental bits to build expanding distributed systems that are capable of being maintained, of being serviced, of being upgraded with time. Fundamentally, this means that we're going to create a system to create routine access to our assets that occur in LEO and beyond. That's the template we want to move to. Now I want to shift gears very slightly for a little bit to basically ask, what's the value of exploring? Why do we explore at all? And you may question my use of the word exploration. You may think I'm talking about utilization, but I'm not. I think exploration, I think the meaning of that term has been debased in recent years. Fundamentally, I think humans developed the exploratory urge because it conveyed an evolutionary advantage. It allowed us to predict where we might find better food, better shelter, better mates. All those things fed into the impulse to be curious, to look over the next hill, to find out new stuff. At the same time, the exploring impulse broadened the intellect and the imagination. Because people had broader and deeper imaginations, they were able to visualize possible solutions to problems that otherwise they wouldn't have been able to do. So in the long run, exploration gave us an advantage not only in survival, but also in thriving and in multiplying, because we were able to envision solutions to problems that otherwise wouldn't have occurred to us. And also I think that the act of exploration inspires the productive and creative segments of society. We see new things, we see bizarre things, things that we couldn't have imagined, and that broadens both the knowledge base and the imagination base of humanity. Now, exploration and science are not the same. A lot of my colleagues seem to think that they are. But fundamentally, exploration is a very different activity. It's largely a curiosity-driven, curiosity-satisfying activity. It effectively is not directed. It continues in apparently random directions, but in actual fact, new discoveries lead to new avenues of inquiry. And so it has a non-directed, it has structure, but it's not directed. Now, science, on the other hand, is the process by which we explain nature. And exploration, fundamentally enables science. By seeing new things that we're forced to devise new explanations for, you're actually creating the situation where science can advance and progress. So exploration precedes and enables science. The other thing I want to point out is I think that we've come in the last century to misunderstand the original meaning of exploration. I put this quote at the top: "Exploration without science is tourism," and it was uttered by a AA of NASA. And I marveled when I heard it, because in one fell swoop, he consigned Christopher Columbus and Balboa and just about every great explorer that had ever lived to the category of tourist. Fundamentally, the equation of exploration with science is a 20th century artificial invention. It started with the golden age of polar exploration, when Amundsen and Scott were racing to the poles. It became a nationalistic endeavor, a projection of power politics. Science was tacked on as kind of a justifying activity. But fundamentally, exploration is more important than science because it is broader and richer than science. It includes both asset creation and wealth generation. Science is fundamentally simply the answering of specific questions. And finally, exploration enables science. And I've got two pictures. One is that of the HMS Endeavour, which of course is Captain Cook's journey around the Pacific. Added greatly to our scientific knowledge, but no one ever claimed the Royal Navy was interested in science per se. And the Scott Amundsen base at the South Pole. Again, an enabling science asset caused by exploration. Now, why people? Why do we need to send people? Why can't we do this all with machines? Fundamentally, I think that humans bring unique capabilities to exploration. They are intuitive and they're able to adapt to changing conditions. They bring expert knowledge to bear on specific problems. They can recognize key significant details out of a myriad of confusing observations. From billions of bits of data that our senses receive, we're able to zero in on exactly what it is to specifically answer and address the topic that we're investigating at any given time. They also combine great manual dexterity with this expert knowledge, so they're able to build and maintain complex equipment, which is very difficult for a machine to do. Robots are great. I've spent most of my life in the robotic space program. I love them. However, they are limited. They're fundamentally limited to what they're designed to do. They can only investigate questions they're specifically designed to answer. So we don't know ahead of time what the most important and pertinent questions are. The ultimate rationale for human spaceflight is fundamentally different, and it relates to species survival. And one of the big scientific benefits from Apollo was that we found out that hypervelocity impact is one of the fundamental processes responsible for not only for the creation of the planets, but for the ongoing geologic evolution of the planets. We also found that these impacts occurred throughout Earth's history and may be responsible for giant mass extinctions. Now, it's not a question of, is this going to happen? It's a question of, when is it going to happen? So the simple fact is, if you want humanity to survive, you're going to have to create multiple reservoirs of human culture. And the way to do that is to expand human civilization off the planet. I want to point out a key document that came out in about 2006 by John Marburger, who at the time was the head of OSTP, the President's Science Advisor. It's a very interesting speech. It's largely overlooked. But fundamentally, what he argued was that the reason we have a space program is to use space for the benefit of humanity, which I thought was a very interesting perspective. Fundamentally, he argued that we should incorporate or plan or try to incorporate the solar system into our economic sphere. So effectively, this is almost the antithesis of the classic Van Allen, Saganite scientific preserve that the space program has always been. This was saying that no, space is an endeavor that humanity is involved in for multiple purposes. Science has its place, but economic growth has its place as well. So if you look at all these policy documents, and I'm including not only this speech, but also a bunch of many books and thoughtful articles by a lot of people over many years, you see common themes that start to emerge, that fundamentally we need to have a program that we can afford and that will continue. We need to explore with humans and machines. Either one or the other is not sufficient. We need to create test beds and systems to learn how to do things in space. Fundamentally, all these things lead up to a statement of mission. And so what I'm going to call the statement of mission as far as relates to the moon is, we're going to the moon to learn the skills that we need to live and work productively on another world. So what am I talking about? Well, I think they can be broken down into three categories. You want to arrive, you want to survive, and you want to thrive. When you arrive, you create a transportation system that routinely gets you to the various places that you need to go for whatever your purposes are. To survive, you need to be able to build habitats that allow people to live on other planetary surfaces in relative safety and comfort, and to conduct productive work while they're there. But ultimately, you want to thrive. You want not only to just get up there and survive and eke through a mission by gritting your teeth and holding it in for a week, you actually want to be able to create a product that makes money. You want to export product for a profit. Effectively, you want to create an economic sphere as part of your movement into space. So what kind of space program are we talking about here? Are we talking about a conventional one, sort of like the one we've had for the last 50 years, or are we talking about something fundamentally different? Well, originally, the space program was basically an instrument of national policy. It was involved heavily in geopolitics, the race to the moon. However, we found, as part of this, that we had a lot of good byproduct from the space program. Byproduct that, in fact, created economic growth and created wealth. So, despite this, despite the fact that space, quote, applications or space utilization or whatever phrase you want to use has already documented its value many times over, in terms of a national civil space program, we seem wedded to the idea of PR stunts as goals. So right now you hear talks about human missions to asteroids or human missions to the moons of Mars. You don't hear talks about human missions to establish a resource base on the moon. I contend that to create real sustainability, to create a real lasting federal civil space program, you need to have value for the money spent. Fundamentally, space must be relevant to national scientific, economic, and security needs. And in fact, that very phrase was used in the founding documents for the Vision for Space Exploration in 2004. Now, it's a different country than it was 50 years ago. I mean, it's not the Apollo age anymore. There's a different geopolitical landscape. Effectively, we don't have the same sense of urgency. When we were racing the Russians to the moon, people put in 18-hour days, not because they were told to or because their bosses directed them, but because they wanted to. They thought they were doing something extremely important. It seems that through time, the productive segments of the agency have shrunk and the non-productive segments have grown. And what's more, that's true not only of NASA, but that's true of our entire technical industrial infrastructure. It's very hard now to get the kinds of innovation and technical expertise and know-how that was very common during the height of the Cold War. We're in a constrained budgetary environment. I'll talk a little bit more about this at the end, but the perception that NASA had a blank check is not quite true. They had to basically fight for their budget every year just like we do now. However, the perceived political urgency was different, and so therefore it was a much easier fight, and they got key allies much more easily than people do now. And finally, I think there's a general risk aversion in this country. I've actually heard someone fairly high at NASA say safety is our first priority, which when you think about it, then that's an argument not to go anywhere. Because if safety is your first priority, then there's no reason to go anywhere. The ultimate safe mission is the one that doesn't get off the planet. Now, what do I mean by cislunar space? I'm talking fundamentally about the volume of space between the Earth and the Moon. It includes LEO, it includes the middle Earth orbits, geosynchronous orbits, highly elliptical orbits, and the Lagrangian points. And different levels of these zones in cislunar space contain different space assets. Various things like communication satellites, like GPS, like national surveillance satellites. All of these assets are in this zone of space, and all of them are between Earth and the Moon. Now, I actually think there's an analogy here, and if you can think back a century ago, there was a man named Alfred Thayer Mahan who was a teacher at the Naval Academy. He wrote a book called The Influence of Sea Power on History. Fundamentally, he argued that great powers that were able to project power on the ocean protected trade and commerce as well as their own security. And the converse was also true. If you weren't able to do that, then your security and your commerce was at risk. So effectively, his argument was that benign powers, and he identified specifically, in this case, the British Empire and the United States, is good for everybody, because not only do they protect their own commerce, but they also protect the commerce of the world. They basically make the world safe for free markets. Now, from the shuttle and station programs, I think we've learned some very valuable lessons. And you can break this down into a long digression on this, but I think the most important thing we learned was the value of people and machines servicing and building distributed systems in space. And you can specifically cite the Hubble Space Telescope, which when launched was basically an orbiting piece of junk. But thanks to the efforts of people on the ground and people in space, it was made into the premier scientific instrument of our age. In addition, we actually built the most complex, heaviest, biggest spacecraft ever, and we didn't build it on the ground. We built it in Earth orbit, and that's the ISS. Both of those programs showed us that this is possible. They also showed us that it's not possible to do solely with robotics, solely with machines, but it is possible to do with a combination of the two. So fundamentally, what I'm arguing is that this paradigm, which has been bought very dearly in terms of cost and effort, should not be thrown away, but in fact should be applied to trans-LEO space, to cislunar space, because those assets that are there currently cannot be reached by people and machines to do that kind of work. Oops, next slide. So, I'm going to basically break this down into two pieces. I said what the problem was. The problem was of the Earth's gravity well. The solution is broken down into two parts, the goal and the mission. The goal is to expand human reach beyond low Earth orbit. And by human reach, I mean the ability to send people and machines to whatever point you want to basically do whatever job you can envision or whatever job is needed. The mission, the way to do this, is to basically use the moon as a logistics depot. So the moon becomes not only the first goal, the first destination beyond LEO, it becomes an enabling asset. It's no longer just a place where we go and repeat Apollo, or explore and plant a flag, or do a rover mission to collect samples. We can do all that, but the real object in going to the moon is to use what the moon offers to create this new capability. Now, this is the talk that Tony Lavoie gave this morning. Some of you were at it, but fundamentally it summarizes a paper that he and I wrote this past year. I presented at Space Manufacturing 14 last year at NASA Ames. Fundamentally, what we've done is to take the runout budget that was provided to the Augustine Committee in the 2009 report, and remember, their conclusion was that we couldn't really do anything with that budget. NASA, in fact, wasn't capable of doing anything without a significant increase in the amount of money. I didn't believe that then, I don't believe it now. We took that budget and basically said, given that amount of money, that rate of growth in the budget, that amount of spending, can you do anything with it? And the answer is, yes, you can. You can create a program with small, incremental, cumulative steps that use robotic assets teleoperated from the Earth. The moon allows you to do this because it's close. It's the body in space that we can actually do this in near real time, operate robotic assets from the Earth, and basically start emplacing a lunar outpost using these robotic pieces. And we've created a program that basically spends under the Augustine cap over the course of 16 years. The total program cost is about $88 billion. Now, if you remember a few months ago, there was a report on a study that was done by some people from Georgia Tech where they looked at an asteroid mission, and they were very proud that they got a mission to an asteroid by 2026, and I believe that, or actually it was by 2030, and they spent $90 billion. And from that, they got one human mission to an asteroid, to a near-Earth object. With this, we get a working lunar outpost capable of producing 150 metric tons of water per year, and then starting exporting that material into cislunar space. So how do we do this? Well, fundamentally, the idea is to use robotic assets to the extent possible to pre-emplace as much as you can on the moon before people arrive. So people's time, I think, is very valuable. And if you're going to have human spaceflight, you want them doing relevant, important things that machines are incapable of. So do all the things that need to be done that machines are capable of with machines. In other words, don't use people as machines, use people as people. And use robots to actually pre-emplace the lunar base. So effectively, the object here is to get a working propellant production quality plant operating on the moon, largely telerobotically. I just got 2 slides. You can read our paper, which is downloadable on my website. I'll give you the URL at the end. And you can see all the details about this. We've got all the masses, all the power, all the costs worked out. But fundamentally, what I've done here is to summarize this in 2 slides. And it begins by emplacing communications assets in lunar orbit, so we're able to communicate with these robots down in the polar dark. You start prospecting, looking for the best sites, the highest grade water deposits you can find. First, you demonstrate that you can dig up this feedstock and extract the water. Then you bring the equipment needed to actually start making real production quantities of this water. So fundamentally, you collect the water, you can store it in the cold traps, it'll stay there forever, they're very stable. You can crack the water into hydrogen and oxygen and cryogenically freeze it to make propellant. Now there's a bunch of supporting equipment. We've got 3 classes of lander. We've got a human lander that's fundamentally reusable, and basically we create a system that can routinely access the lunar surface. It's reusable and extensible. So what does this give us? Well, fundamentally, by doing this program, you're able to do 2 things. First, you're able to create a viable, exciting, and productive space program that returns value for investment for the tax dollar, and gives NASA a challenging task to do. But after you've done it, you've effectively created a system that can be expanded upon and built upon that will allow you to get routine access throughout Cislunar. So not only can you access the lunar surface, you can access all the L points, you can access geosynchronous, you can access any asset that's in this volume of space. And oh, by the way, if you can do that, you can go to the planets as well. So what is the value of lunar resources? Well, their value is everything. Effectively, they are the key that allows us to break the tyranny of the rocket equation. By going to the moon and using the water that you find there, you're actually able to create a system that's extensible, maintainable, and reusable. So fundamentally, the moon's value here is to become our first logistics depot off planet. And if you're ever going, as we expanded throughout the West, no one from the East Coast brought all their supplies with them. They created trading posts, and they created supply areas where they could refurbish themselves with what they found along the way. All I'm proposing is that fundamentally we apply that same paradigm to spaceflight. Now I want to close by basically addressing the giant elephant in the room, and that is, given the horrendous financial straits this country finds ourselves in, what am I smoking? Am I crazy? Is this actually possible or not? Well, fundamentally, I contend that because space and the space program and the use of space-based assets is so intimately woven into modern industrial technical life, that fundamentally we will have some kind of space program. It's not clear what its scope is, who actually is going to run it, what different kinds of functions it's going to carry out. But the idea that we would not have a space program is ludicrous. We will have one of one type or another. So the question simply becomes, what are you going to spend and what is it going to cost? I contend that doing this is actually returning value to the public. And I want to specifically address this issue that a lot of people talk about. It's not exciting. We've got to excite the public. I don't think the public is really looking for excitement. I mean, if they know how to excite themselves. And the analogy I make is you can go to the circus and you can get excited. And that's what we've basically turned the space program into a circus, into a carnival. We want bigger and better thrills. Come see the giant bearded lady and come see the first human footprint on an asteroid. But that's not value for money. Instead, if we took that money and invested it in building a railroad. Now that wouldn't be exciting to anyone, but it might actually be useful. It might actually be able to generate wealth rather than consume it. So fundamentally, I'm arguing that what we want is we're going to spend money on space. We might as well spend it on something that gives us something in return. Now, there's one other thing I want to touch on, and this idea of coping with limited resources. And those of you in the audience who are Civil War buffs will recognize these 3 gentlemen, and I picked them because each one illustrates a different coping strategy. The first one is to basically run away, and that seems to be the current policy for NASA. The general that I picked is Gideon Pillow, who is in charge of Fort Donelson, and you might recall that he surrendered after Grant basically cut off his supplies, and one general that was under his command, Bedford Forrest, was so incensed that he demanded to be released, and he and his men were going to cut their way out, and they did. And they went on to become the biggest pain that Grant had in that campaign to follow. Another strategy is to constantly demand more and more resources. And the guy I picked here is General George Brinton McClellan, who basically told Lincoln he could march on Richmond and take Richmond, and all he did was continually write Lincoln with letters asking for more men, more material, and more money. Or finally, you could do the job with what you've got. And my icon there is U.S. Grant, who fundamentally decided that he had an army, he had the resources, he was going to do what he could with those, no matter how long it takes. Now that's the attitude that we need to adopt with our space program. It doesn't matter how much we spend per year. It matters what you're trying to do, and it matters how you're trying to do it. So what we need to do is shift from this idea that, well, if we just had another $3 billion a year, we could do all these great things. We can do great things now. We just need to figure out a clever way to do it. I think that we're in a very early stage of understanding how to live and work in space. I don't consider that we ever actually lived in space. We visited, but we don't know actually how to live there, because a key thing of living anywhere is learning how to use what resources you have there. I make this analogy. I think at this stage we're basically the baby in the cradle. We're in the cradle, just like Tsiolkovsky said many years ago, and to get out of the cradle, we have to first learn how to stand and crawl and stand, and then we have to learn how to walk. And we're not there yet. So effectively, we've got a lot of work to do. Thank you very much for your attention. If anyone has any more questions on this, please go to my website. I have the paper that Tony and I wrote available for download, and any other thing, a lot of other interesting things there. I also want to put up at the end a slide that kind of summarizes this argument in 9 easy steps. Thank you very much.